Alright, welcome back. MECH2320. We are going into Chapter 4 here. We're going to be discussing overload relays, what they are, alright, and kind of some different ways that we protect equipment in the field when it's operating. Alright, so we're going to talk about, what's the difference between a fuse and an overload relay type thing. We want to talk about different type of overload relays, all right, and how thermo overloads actually work. Okay, and then we'll talk about a couple other methods as well. But this should be more from electrical here. Fuses and breakers that protect a circuit. Okay, so remember when we have a fuse is a one-time use. Okay, so in your vehicle you have fuses, right? Under the hood, maybe some in the glove box, different fuses. We're protecting some DC stuff, right? So, you have a different fuse for your stereo, your turn signal, your blinkers, your dome lights, all those different things in your vehicle. So, if we blow a fuse, like the multimeters in class, if we put the current in wrong, we can blow a fuse. So, fuses are one shot, replaceable. All right, we use them to protect equipment. It's the wire between them that snaps when too much current goes through it and protects the equipment. Alright, circuit breakers, that's like what you have in your house, alright, and they're not just your house, but they're all over. We have panels here in the classroom and things like that. So circuit breaker trips if there's more than what's allowed on it. So like if you have a 15 amp breaker in your house and you plug too many things in and turn them on, okay, that breaker is going to trip. It doesn't mean we have to replace it like you do a fuse. We unplug what's causing the trip, because you're pulling too much current, so that's why it's protecting the circuit. If it's a 15 amp breaker, you can't go over 15 amps or it'll trip the circuit. So you go back to your house, unplug everything you have plugged in, and you set the breaker, you reset the breaker, okay, back to on, and everything works good. So, it's like one of those things you got to pay attention to. I had a scenario, my mother-in-law lived with us, and she was using, 150 watt light bulbs in a 75 watt fixture for a lamp, and that tended to draw too much current and kept tripping. So we had to have a discussion that you have to read labels and make sure that we put the right bulbs in the right type of lamp fixtures and things like that, because she kept tripping the breaker in the house. So just different things like that. So fuses, one shot. Breakers, another, we can use them over and over and over again, but they're protecting the inrush of current. So you're protecting the equipment that's being plugged in, essentially, because if it draws too much current, you can burn up the motors. Okay, so that's really essentially what you're going on. Fuses, right, we're protecting all of our electronics from frying and overloading. So, and then we're going to talk about overloads. That's another way we protect the motor. Okay, so what we have, it's with overloads, they have some sort of way to detect the motor current. So every single overload we're talking about, even fuses and circuit breakers, right, we're detecting the amount of current. Okay, they don't have a current reader on them, but based on our properties of current, right, current gives off heat and it gives off a magnetic field. So we're going to use those two things against it to help protect our equipment. So we have a current sensing section for it, okay, which is the field or the heat given off of it, and then we have contact section. All right, so what that's for is we can understand in the PLC what happens. So we have communication with the PLC as well. So we physically protect the device, and then we let the PLC know, hey, this is what tripped, and here's why. All right, so we have something called like a dual element fuse. This is a little bit different than any of the fuses that we have in class. Okay, but what happens here is it's kind of like solder, right? And it uses a type of solder essentially. So when we were soldering circuits in class, right, you would put the solder on the iron and it would, solid solders, it's soft, it's flexible, but yet it still had to get to a certain degrees to melt and liquefy. So that's kind of what happens with this. We send enough current through it, so what will happen is it will heat up, okay, and once it gets to that specific temperature and the solder starts to liquefy, all right, okay, it'll slide apart. It allows it to slide. So it's a time delay fuse, because sometimes we have an inrush current and we don't want to trip the motor, but then the motor can get to speed and the inrush current drops back down to normal operating. So we don't want to constantly replace fuses. We have a time delay. So if it draws too much current for too long, then it will break. But if it draws a lot of current and then kind of sips back to normal, all right, that solder will re-solidify because it won't be hot enough to melt it. So the fuse won't necessarily trip. So that's why we use time delay fuses. We're still protecting equipment, but sometimes that equipment needs that inrush current to get going, to get the rotor going or something like that on a motor. So we don't want to trip a fuse every time, and it'll still allow it to run, okay, because the temperature from the current won't be hot enough to melt the solder. Okay. So if we use a thermo overload relay, okay, very common here, we connect the heater in series with the motor. All right, so the amount of heat on that depends on the current. So remember, as current goes through a wire, it gives off heat. So when you have like a little space heater, remember those are just coils of wire, and you're putting current through them, and that's why they glow and give off heat. Same if you have an electric stove. All right, that's just a coil of wire essentially, and you're heating it up, doing the same thing. So different ways, the solder melt that we just talked about, or a solder pot. Okay, we're going to talk about those a little bit. And so it's really just, a brass metal shaft is placed inside a brass tube. Okay, we're going to get into like a dashpot and things here in a little bit. Okay, or we can have a bimetal strip overload relay. So heat causes the strip to bend. Okay, so that's really what's going. We're using the heat, against it. So here's what's going. If we look at a solder pot here, okay, it's kind of like what we talked about, right? We know that solder is sensitive to heat. So if it's not hot enough, solder won't liquefy and it'll still hold it in place. Whereas it gets too hot, the solder will liquefy, okay, and then it'll allow it to slide. It'll allow that shaft to slide. Okay. If we're looking at the bimetal strip, all right, if there's too much heat going through it, it begins to warp. When it warps, all right, it opens the circuit up and the circuit trips. So that's really kind of how those work, just based on temperature. Okay. So thermo overload relays, we have these on all of our motor starters. You're going to see them on all the schematics we do, everything you're wired. They're built into our starters and our contactors and things like that. So it's not something separate. I mean, you can add some separate pieces, but for the most part, it's kind of an all-in-one unit. But all three-phase motors must have overload sensors. Okay, some sort of way to protect the motor from overloading, because if you are giving it more current, it can actually do damage not only to the motor but to whatever equipment that's in the process. Think about a motor. We got a conveyor, right? And the motor is running the conveyor, and there's something too heavy on the conveyor, but the motor is going to pull in as much current as it possibly can to try and keep that conveyor going, because that's all it knows that it can do. And when that motor pulls in so much current but still can't move, you begin to start frying everything on the inside. All right, so we have magnetic overload relays. Okay, they're not using temperature here. We are using the magnetic field giving off current. Right, so remember in electrical class we talked about like the left-hand rule. When you put your thumb in the direction of current, all right, and you curl your fingers in the direction of the magnetic field. Well, remember, as we have more current, we're going to have more hysteresis, right? So our magnetic field is going to increase. So based on the magnetic field, we can detect, how much current's going through there and trip based on that. Just the same way we use like a clamp ammeter and things like that to read it. Okay, so we can use the electronic and the dashpot methods. Okay, and we'll get into the dashpot piece here in a little bit. All right, but we can also use a current transformer. All right, so it's really sensing the current based on the induced voltage now. So we're doing it that way. So we can detect what the voltage might be based on what the current value is, and you can change the sensitivity of it whether it trips. You're going to do a lab where you're actually going to trip it on the Future Tech trainer in here. You guys are going to wire it up, and then you're going to dial it in, and you're going to adjust the settings so that it actually trips. So you guys will be using a current transformer on that lab to do it. Okay, this one's a little bit different. This is a Dashpot Timer. Because, like I said earlier, when we had the other type of heat fuse, all right, sometimes we want a large inrush current to get the motor going, okay, but we don't want it to operate at that. It's just an inrush. So we put a Dashpot timer on there. So it's a time delay. So what happens here is we're using a solenoid essentially, right? We have a coil of wire and we're putting current through it. It detects, and as that current, it's not detecting the current, it's using that current. So as that current rushes through, right, it creates a magnetic field. Now, that magnetic field pulls on the plunger, but the plunger is being restricted because there's specific Dashpot oil in there that has specific viscosity for specific temperatures. All right, so that magnetic field, that plunger still has to overcome the fluid of the oil. All right, so based on that, if the current, rushes in, it's going to move that piston enough to where it'll start to pull it up. But if it levels back out, all right, that piston will stay in place, okay, and we'll have our contactors closed. But what will happen is if that inrush current is too long, okay, based on whatever the time delay is on the oil and the piston and all the other properties that go into it, okay, it will open the contactors and protect it. All right, but we're using the current itself and the magnetic field of the current to control how far that piston goes. All right, and remember the oil that's in there is really just to slow down the piston so that it doesn't trip right away, so that it gives that time delay for that inrush current and for the current to level back out to normal operating speed. Okay, so that's really kind of what goes on there. And then it has the holes in the piston so that the oil can go through from one side to the other. Okay, it's just a single acting type piston. Okay, all right. So when we have overload relays, we also have the contactors. I mentioned that in the beginning. Okay, so we might have a single pole throw switch or two separate contactors. Your three-phase will have a contactor for each phase. So we use the contactors there so that the PLC knows that we've overload as well. So not only do we have the overload relay, so if we take a look on the schematic here, okay, and we look at the contactors. If we look at the motor, what's directly connected to the motor, right, that's our thermocouples, or those are what is actually detecting, the heat for the current, for the overload. And then each one of those has a contactor that goes with it, okay? You see those at the top of the diagram there. So when those open up, the PLC actually knows, okay, oh, we're tripped or the motor's off. So it's very, very important that we have those. So that's for communication purposes. The contactors themselves aren't what's protecting the circuit. Okay, the overload relay, the thermocouples that you see there connected to the motor are, but those are tied to contactors on there. So they kind of all work in unison. So that's really why we have those on there. Okay, so we also have current transformers. Okay, so a common one that we use is a 150:5 ratio. So we use the primary side of the transformer for 150 amps, and it reduces our secondary to 5 amps. That's how we can really, control that inrush current as well. We use this on large horsepower motors, so we're going to use a transformer there. They're very notable, so you can see the picture in the bottom right-hand corner. What the transformer looks like there as it steps down. All right, so we will use a step-down transformer. And you can, I have some in class. We have it in the big cabinet in the back, so I'll show you guys in my classroom what those look like if you want to see. Okay, but the whole point is to control the motor, because motors need to operate at a specified current. All right, so small calculation here. Let's say we have a three-phase motor that has a full load current of 140 amps. What current would the overload heaters be sized for? All right, so we take that 150:5 ratio for the transformer, and we set that equal to 140 over X. All right, so solving for X, we end up with 4.67 amps. Okay, so that's what the overload heaters have to be sized for. They have to be able to handle at least 4.67 amps. Okay, normally you might size those up a little bit. You don't want to size right at that specified value, because then it'll trip if it goes up. Okay, but for the most part, You usually take 125% of the motor full load current is generally how you size everything, and that's specified in the National Electric Code Book. Alright guys, well that's the end of this lecture. As usual, email me if you got any questions, or let me know if we need to Zoom meet or team meet about anything else. Your assignment's online. Guys, have a great day, and I will see you in class.